All right, let's talk about one of the biggest challenges in tech, software design. It can feel, well, huge and complicated. So today, we're going to peel it back layer by layer, kind of like an onion, to really make sense of it all. I mean, we've all been there, right? Doesn't matter if you're a seasoned pro or just starting out. You have this clean, simple idea, and then somehow it morphs into this tangled mess. It's hard to understand, a total pain to change. So how does that happen? How do we go from a perfect, clean slate to this labyrinth of code? So you go looking for help, right? And what do you find? A total battlefield. You see these debates online. One person screaming that don't repeat yourself, or DRY, gets twisted into these ungodly abstractions. But then someone else fires back that things like YAGNI, you ain't gonna need it, just make developers lazy and short-sighted. It's just a mess of acronyms and super strong opinions. Okay, so let's cut through all that noise. The bottom line is this. The number one goal of good software design is just managing complexity. That's it. It's not about being the cleverest programmer in the room. It's about building something that's organized, something you can actually understand. It's about stopping that simple idea from becoming a total nightmare. So here's how we're going to tackle this. We're going to start with the big picture, the system blueprints. Then we'll zoom in a bit to reusable design solutions and the principles that guide us. After that, we'll get our hands dirty with the art of refactoring. And finally, we'll get to the core of it all, why code is really for humans. All right, let's start way up high at the 30,000-foot view. We're talking about the big ideas, the philosophies, and architectural patterns that shape an entire system from the get-go. You know, before a single line of code is even written, a lot of projects start with a philosophy. Take Agile, for example. It's not a technical thing, not a blueprint. It's a mindset. It's all about focusing on people, on working together, and being flexible enough to change course, instead of trying to plan everything out perfectly from day one. It really sets the stage for how a team is going to work together. Okay, now let's get a bit more concrete. Let's talk architectural patterns. Think of these like the actual blueprints for a house. A really common one is the layered architecture. It's all about separating things out neatly. You've got your UI layer, your business logic layer, and your data layer. Clean. Then you have something totally different, like microservices. This one breaks the whole application up into tiny, independent services. It's amazing for scaling up and letting different teams work on their own piece of the puzzle without stepping on each other's toes. And then you get into some really specialized stuff. Take the space-based pattern. This thing is all about raw performance. So what's the big idea? It gets rid of the central database, which is often a huge bottleneck. Instead, all the data lives in memory, spread across a bunch of different machines. This means you can scale like crazy. If you need more power, you just add more machines. It's an incredibly powerful tool, but you'd only use it for a very specific type of problem. Okay, let's peel back another layer of the onion. We're moving from those huge, system-wide blueprints down to the individual building blocks of our code. We're talking about design patterns. And really, they're just well-known, reusable solutions to problems that pop up over and over and over again. This whole idea was really kicked into high gear by the famous Gang of Four book. And their central point was, honestly, revolutionary at the time. They said, hey, most of the problems we're trying to solve, someone has already solved them. So by giving these solutions names, by documenting them as patterns, we create a shared language. We stop reinventing the wheel constantly, and that, in turn, makes us much better designers. So what does one of these patterns even look like in the real world? Well, let's take a classic, the observer pattern. Just think about a spreadsheet. You change a number in one cell, right? And instantly, all the charts and formulas that use that number, they all update automatically. That is the observer pattern. It's basically a subscription model. You have a bunch of observers that get notified whenever the thing they're watching changes. It's simple, it's powerful, and you see it absolutely everywhere. Now, this is a super important point, and it trips a lot of people up. A design pattern isn't a piece of code you can just download and plug in. It's not a library. It's a blueprint. It's the idea, the strategy for solving a problem. You still have to implement it yourself in your own code, in your own way. You're reusing the concept, not the code itself. All right, next layer. We've talked big picture architecture. We've talked reusable patterns. Now let's get down to the principles that should be in your head every single time you sit down to code. Think of these as the rules of the road. And you can kind of split these roles into two camps. First, you have the principles. These are the good habits, the things you should do, like dry, don't repeat yourself, which is all about avoiding copy-pasting. Then you have the flip side, the anti-patterns. These are the common traps, the things to watch out for and avoid. A great example is dead code. It's code that never, ever runs. It just sits there, creating clutter and confusion for anyone who stumbles across it.
But here's the thing, and it's a big but. These are guidelines, not gospel. You can't just follow them blindly. Like this developer is saying, sometimes if you try too hard to follow DRY, you end up building this crazy, complex abstraction when just a little bit of repetition would have been way easier to understand. The real goal is always clarity. It's a judgment call, every time.
Okay, we're finally here. We've reached the very center of the onion, the code itself. This is where the rubber meets the road, where all those high-level ideas actually have to work. And this brings us to the daily craft of making code better, something we call refactoring. So what exactly is refactoring? Simply put, it's cleaning up your code. But the most important part of that definition is this: you're changing the inside without changing the outside. The code still does the exact same thing. You're not adding features, you're not fixing bugs, you're just improving the internal structure to make it cleaner and easier to work with in the future. It really is like cleaning up your workshop so your next project is easier. Let's make this real with a classic example from Martin Fowler's book. So here's the before. This function is a beast. It works, sure, but it's a total mess. It's trying to do everything at once, calculating prices, figuring out reward points, formatting a receipt. It's all crammed into this one giant confusing block of code. Seriously, if your boss told you to change the price for comedies, you'd have to spend an hour just trying to figure out where to even look. And here's the after. Night and day, right? This is what refactoring does. It's the same functionality, but look how clean it is. All that messy logic has been pulled out into small, simple functions with really clear names. Now the main function just reads like a simple list of steps. It's easy to follow, and if you need to change that comedy pricing, bam, you know exactly where to go. No more hunting.
So we've gone on this whole journey, right? From the 30,000-foot view all the way down to tweaking a single function. It's time to zoom all the way back out and ask the big question. Why? What's the ultimate goal of all this effort?
And this is the answer. The whole point of all this, the patterns, the principles, the refactoring, it's not for the computer. The computer doesn't care. It's for people. It's for the next human who has to look at your code. And like Martin Fowler says, a lot of the time, that next human is you 6 months later when you have absolutely no idea what you were thinking. Good design isn't just a technical skill. It's an act of kindness to your future self and your teammates. And that leaves us with one last big question to chew on, especially now. As AI starts writing more and more of the actual code for us, where does that leave us? Does good design matter less, or does it suddenly matter more than ever? Maybe our job is shifting. Maybe it's less about laying every single brick by hand and more about being the architect, the one who designs the blueprint, who chooses the right patterns, and who guides the AI to build something that's not just functional, but also robust and understandable. Is that the future? It's a huge question, and it puts all of these timeless principles right at the center of what comes next.